Okay, question 23. We're told that these 5 terms are in a geometric sequence. So this is A. This is AR. This is AR squared. This is AR cubed. And this is AR to the 4th. Now, to find the next term, we need to find what R is. Well, we can find that out from the first 2 terms. AR over A is equal to 10 over the square root of 5. Therefore, R is equal to 10 over root 5. We can leave it like that, but if we rationalize the denominator, so we get 10 root 5 over 5, so R is equal to 2 root 5. So if we need to find the next term, the 6th term equals 400 root 5 multiplied by 2 root 5. So that's 800. 800 times 5 is 4,000. And that's your answer. Now let's have a look at part B. We've got a different geometric series and we're told what the 4th and the 6th terms are. Well, if this is the 4th term, 1, 2, 3, 4, this is AR cubed. And the 6th term will be AR to the power 5. So I can say that AR to the 5th power divided by AR to the 3rd power, which is equal to R squared, is equal to this guy, which is 5 root 2, divided by 8, big divide, 5 root 2, divided by 4. These 2 terms will cancel, and we're left with 1 over 8, divided by 1 over 4. And this is equal to 1 over 8, multiplied by 4 over 1, and that's equal to a half. Remember, that's R squared. Therefore, R is equal to 1 over root 2. And because we're told all terms in the sequence are positive, I'm just going to take the positive result of R here. But let's see what happens. Okay, so I can now say, to find A, let's take the AR cubed term. So A multiplied by 1 over root 2 cubed must be equal to 5 root 2 over 4. So all we've got to do is solve this. So therefore, root 2 times root 2 times root 2, the denominator here, will be 2 root 2. So A divided by 2 root 2 is equal to 5 root 2 over 4. Multiplying both sides by 2 root 2, this is equal to 5 root 2 multiplied by 2 root 2 divided by 4. Root 2 times root 2 is 2. 2 times 2 is 4. So effectively, all these terms cancel with the 4. And we're left with the answer of that A is equal to 5. A rather satisfying answer. And we were right to ignore the negative result of R here when we took the square root. So we're okay.